Thank you for attending the East Bay Agilistry and QA Meetup Group, sponsored by QASource. We are fortunate to have James Pulley presenting Ask a Performance Question. And now we will jump into James's presentation.
Be how fast, or other attributes associated with performance. And this causes a problem. Going back to whether it's waterfall, agile, DevOps, Bob's process, Azure, we have this issue of when we speak to our audiences, we have these differing standards for what constitutes performance, or different assumptions. Whether we're looking at our business community, our sponsors in this case, whether we're speaking with architecture and how they're working with the information that comes from the business needs, whether we're looking at operations and how they are measuring what's going on in production, or we are looking at development. And there are some things that are binders to this whole process, what we do and how we do it and what we expect. These generally are user stories, our requirements, our desirements. They bind us together as a glue. But what happens when you don't have these performance attributes? Well, each one of these groups goes off on their own and makes some fundamental decisions on what proper performance looks like. If you never ask the business community what they expect, hey, if they just say fast, and that's left to interpretation, well, you're going to get architecture saying, well, fast, we're sufficiently unique and no one can go anyplace else and do anything like what we do, so 8 seconds is good enough. Development is going to say, well, fast enough is 4 seconds for X widget, it's 10 seconds for Y widget. You know, you're going to have all of these individual developers making these decisions on their own. And then you're going to get to operations. And operations, let's say it's an e-commerce application, they're going to say, well, gee, sure, we sell a lot of unique stuff, but we sell a lot of competitive brand things as well. And if it goes over 2 seconds, people are leaving our site and our conversion rate goes down and our revenue goes down. And the business, circling right back again, we've all been in a meeting where we ask about performance information at some point, and the business says, well, I don't know, what do you think? You have to get it in concrete and everybody needs to be on the same page. Otherwise, I'm going to show you what happens most commonly to performance practices across waterfall, agile, and DevOps. And you may find this funny. As we go back and we recover all of these assumptions, desires, requirements, desirements, whatever we want to call them, we're left with this hybrid collection of what assumptions were made by the business, what assumptions were made by architecture, what assumptions were made by development, and what operations wants to see, and it almost never matches up to what really needs to occur in production. You know, we see a very comical example here. You know, this is kind of a flight school photograph, but you can imagine this is, in fact, what the typical performance test looks like. We have a set of requirements that have built the airplane from development and from architecture, which may not match up with what the business wants or what operations needs. And so you have performance tests that's actually testing against maybe business and operations needs, but not exactly what was built by development and architecture, or even, you know, any one little piece of that matching up. And this is why, in many cases, organizations achieve incredibly low value from performance testing, is that you have this late recovery of what should be captured very close to the beginning of the process, and it's very much unfair to the organization because the as-built that's being tested has been built with a lot of other different assumptions that are not associated with the performance test. And that's almost guaranteed to cause organization political problems, getting low value out of your performance test, making it a difficult predictor for what's going to happen in production, and ultimately, in many organizations you see that they just want to cancel performance testing because they're just not getting the value out of it. Well, there is actually a simple way to look at this problem, which is very surprising. Many of you have likely heard of the butterfly effect. Mike, if you're listening, can you bring us up to speed on what the butterfly effect is?
I'm actually not sure.
Okay, well, it was a very bad movie with a couple of years ago, but ultimately the butterfly effect is a concept that comes from chaos mathematics, which is I have a very small element that when it's implemented actually has dramatic change later in the process or later in an equation. The classical example is I have a butterfly flapping its wings in Hong Kong, and a few days later we get a tornado in Kansas, or a month later we get a hurricane that's developed off the coast of Africa. So we have all these little eddies that come off the end of the butterfly flapping its wings, and those grow larger and get combined with other things, and the end result is a dramatic difference at the end of the process. Well, I am going to give you a small change in process which will have a dramatic difference on how performance winds up in your organization. And it's real simple. It doesn't really change how you work together, but it will change the information which is captured and the assumptions that you have going forward. It's really very simple. Whenever you ask a functional question, ask a performance question. And this applies throughout the entire process. So as we're gathering business needs or business requirements, which in turn generate user stories, which in turn generate architectural designs and then development activities, every time you ask, what should this do, you should be asking for other performance-related information from the business as well. Likewise, when you get to asking questions when you're in unit testing, component assembly, in functional testing, you need to be asking similar questions. Sure, we know the page loads. Sure, we know that the page is functionally correct. But how fast did it run? And there are some very core reasons for this. One, there's a rule of thumb, and we'll see this a little bit later, but I'll cover it now. If a piece of software does not work for one user, it will not be performant for multiple users. There are very many times when I go to help customers in a performance testing project that I will find at the inception that the business process I'm testing is not performant for a single user. I can run it through, I can run it all day long, but no matter what I do, the single user won't run fast enough. And that needs to go back through an architectural view of how the page is constructed or how the application is constructed just to get it performant for one user. Now, I've brought forward a number of examples as I've been chatting of what example performance questions might look like, but I'm going to take a step sideways here and move over to a tool that probably every one of you is using today, which is a browser. And if you're not using the developer tools today in your browser, you're really missing out on some opportunity to collect some performance information. So we'll begin with Google. Many of you may remember recently where Google revised their typeface. Does anyone recall why they revised their typeface? Well, they were looking to shave just a few bytes off of every request to make just a small change which has large impacts across their entire organization for how much network bandwidth they need, for how much data storage they need inside of their content delivery networks, etc. So they revised their typeface in order to make it smaller, in order to make it transport faster, in order to make it draw or render more quickly on the client. But the place that you can begin on your developer tools is begin with the audits. All of us have seen these developer tools at one time or another, but the audits are particularly critical for performance. If you notice, it can tell you very precisely what's going on with network utilization or web page performance, whether your bias is inside the network or whether your bias is inside of the client, for some things that you can do to improve performance. Here we have an example for Google: leverage browser caching, minimize cookie size, so there's some cookie complexity there. But what's most important here, which is really interesting, is this concept inside the client for where we're bringing information to the user, is we have to process a number of CSS rules, and we see that we have a number of rules that are orphans. And this happens quite commonly in development practices. We'll create a new CSS rule, we'll try something out, it stays in the style sheet, we never really remove it, but all of that accumulates over time as jetsam and flotsam in the system, and all of those items have to be parsed through in order to render the page. So the smaller you can make those files, hey, the less time it takes to transit the network, the smaller they are in compressed form, the less time it takes to parse them on the end client, and you get a more responsive design. And in many cases, you can make these modifications without a complete redesign to the page. You can simply go through and just remove the orphaned references inside of your style sheets and things of that nature. Now, as an example, I'm going to go over to a local restaurant to me, one I had dinner at last night, Spiro's Hilltop Fish Fair and Steakhouse. If you ever come to Monroe, I highly recommend them. And they have a very simplified web page. You can see it here in the background. It has very much of a late 90s, early 2000 type of feel, not a very responsive design. But you notice it's very, very lightweight. It's we've got just a few issues associated with it. And in fact, it has fewer orphaned CSS rules than even the Google website does. So in certain respects, they're doing something quite well. But there are some things that they are not doing very well, and we'll take a look at those. I'm going to bring up a site called GTmetrix. If any of you are not familiar with GTmetrix, essentially it goes through and it applies a couple of different rule sets: page speed, Y-slow. A lot of these are derived from Steve Souter's High Performance Websites book for how we should be taking a look at performance. And you can see that we have scores, and in certain respects, it's a very lightweight page, 277K, 4-second response time, 12 requests. I would dare say that almost anything we work on these days is going to be fatter, have more requests, and it might load around the same amount of time, maybe a little bit slower or faster, depending upon what you're working on. But notice what we have here. If we're going to ask a functional question, does it work for one? Hey, that's great. Let's ask a performance question. Well, we apparently are not caching things correctly. Apparently, we're not compressing items that we can. And then we have this thing called avoid bad requests. Now what is that precisely? If we go to Y-slow, we can look. We can see we have similar types of items going on. We're having items related to caching at the client. We're having items related to a CDN. We don't have that involved. Compression with gzip. But here's the really telling item on the waterfall. So I have a functional page that it looks okay to the user, but we have this 404 request, which is hidden from the user. So functionality-wise, we may not even see this as an issue as we're going through the site, But this is the dominant item which holds the thread for a long period of time and prevents us from getting, say, under the 1 second or 2 second window, and it takes our page load all the way out to almost 3.5 seconds. Now, this is an example of something that gets hidden under the covers, very often not caught in functional testing. It may be a project orphan. That is, I built a new project, I built a new page, and I had a stub of an element present. And when I built the page, the stub reference didn't come out, so I have this 404 that's constantly in play. Well, this 404 will actually go through your CDN, unless you're configured to cache 404s, all the way to your origin servers, and will cause the longest possible conversation to take place between your client and your server, and it will hold a connection that can better be served to serve content. But these are just a couple of examples of asking that performance question. So wherever you have a functional issue, and we'll go back over to our presentation at this point. Bear with me one moment. Many of the questions that you see on your screen are really associated with different areas of development. For instance, how long you might be asking that of your business owner. The maximum time allowed for marketing beacons. Well, certainly you'll ask that of your business owner. You'll ask that maybe of architecture. I don't know about the rest of you, but I have seen marketing beacons, things like Omniture, Google, Stats, things of that nature, take over half of the total page load on a site. And most of that occurs because different people in the marketing group want different sets of data that come from particular tools. But there is a cost associated with that. This question on should we pass all DevTools audits? That's right there in the browser. You can't deny it. You run it, you get the audit. Should you fix it? And if you shouldn't fix it, do you need an exception before you promote? And here is the large one at the bottom. How does this compare to X? When we get into this issue of continuous development, where we have a new build spinning out every N number of hours, we also need to begin taking a look at how our performance data compares with previous builds and also with a standard. And the reason for that will become obvious in just a moment. So the critical piece here is we want to take those user stories or requirements or desirements, the document that you pulled from archive and referenced, and we want to incorporate all of this information that we are collecting whenever we're having a functional discussion, and make sure that it gets incorporated into every single document. This way we have all aspects of the organization under the same assumptions for performance, and we don't have that issue of getting to any type of performance testing where we have the 42 individuals on the single-seater fighter plane trying to see if the plane will take off, if it will perform loops and things of that nature, when we know that we're going to have issues. And that is ultimately the goal, is to capture this information early and make sure every single person is on the same page. And also, if there's an objection, you capture it very early in the process. Some stats which should scare you. A 2% change or a 2% increase in build to build will actually double your response time in a given area in 36 builds. Now, this comes from a concept of compound interest rates called the rule of 72, which is you take any number divided into 72, and that'll tell you approximately how many periods it takes to double your money. Well, in this case, a 2% build, if you're not looking at the unit test, how long it takes, and it's creeping up by 2% each time, it doesn't take a whole lot of builds, particularly if you're building, say, 8 builds a day. Before the end of the week, you may have doubled your response time. you need to keep a very watchful eye on how you are progressing from one build to the next, or a comparison against that static baseline, which has been captured as a part of asking a performance question right up front. I mentioned this second item earlier, which is the rule of thumb of it cannot scale to many if it's first not scalable for one user. This is very common, and in fact, you see this issue of not understanding performance almost until the end in some environments. I'm working with a company that places candidates in production, and they take this candidate in production and they compare it with the current production usage, and essentially the candidate and the current production object are competing for who is faster. Well, we should never do that. And the reason why is that's incredibly expensive from a cost to actually find and fix a defect. If we look at what Gartner tells us, and Gartner has based their studies on their own research plus prior art that comes out of NIST and a few other organizations, that when you look at the jump from the last stage of development or QA to production, it's about a 10-fold increase in cost. Most of us don't care about that in development. Hey, we're being bonused to hit date X, or we're being bonused to have our build schedule hit every 3 hours. And so we're less concerned about what happens when it gets into production. But part of that not only is, hey, it may not be as performant in production, but there's also the opportunity cost, particularly if you're an e-commerce shop, of lost sales, abandonment of the site, other artifacts that occur throughout the system under poor performance as well. So just keep that in mind. The goal here is to get everybody on the same page, start asking the questions early and often, discover the performance defects early and often and fix them right there, and before it escapes actual development into prod. Ultimately, we want to not only, in addition to establish this common understanding, so people aren't at the very end of the process saying, no, it should be X performance versus Y performance versus Z performance versus we don't need performance at all, is we want to prevent that non-compliant code from being promoted from one stage to the next. We don't want degraded performance to enter the build cycle at all. If unit testing has degraded by 50%, if we're not asking that question, we'll never know, and so it gets promoted. That gets into component assembly. That actually gets into a release candidate. That goes to a candidate in production, and now we're asking the question, is the candidate in production faster or slower than what we currently have? And that gets back to the expense. Collect it early, often, ask a question. When you find it, fix it there, don't promote, and avoid the production issues. I know we've gone through this very, very rapidly, so I want to turn it back to questions from the audience. And once again, the premise of this is wherever you ask a functional question, ask a performance question. Thank you.
Hi, James. That was awesome. Okay, so we have a couple questions for you. The first one is,
okay,
how do you recommend getting management or the testing team to buy into incorporating performance testing with user stories, requirements, and desirements?
Well, that's the beauty of this recommendation, because it is a natural extension of what you're already doing. You're already asking these functional questions. You already have this dialogue ongoing. You're simply asking for one more additional piece of data.
Okay.
And it's quite often you'll be in a room of 5 people and you'll get 5 different answers, and that will surprise all 5 of the people in the room. So now you have an opportunity to add clarity, to capture that and roll it into your user story so that that assumption is carried forward for everyone else to base their activities off of.
Okay. And another question here, I'm not sure if this is more on the topic, but If we have a staging environment for testing, how is it different from production?
That is an excellent question. And there's not really an easy answer to it.
Okay.
And here's why. No matter how you build your staging environment, no matter how you build your quality environment, there are always compromises, and there are non-uniform scales to various tiers. As an example, you might be using the hot system failover node for your database. So it's 100% size to production. It's just, well, if it ever has to fail over, you take low priority and you're done for the day. However, your app servers, there may be 40 in production. You might, and they may be physical servers, but in your confirmation environment or your staging environment, you could be left with 2 virtual machines on a VM host that's running 50 other machines at the same time. So the scale is dramatically non-uniform. And it is difficult to address the question of how do you qualify the risk in that case. Mm-hmm. A number of years ago, I had to address this question for a company that was acquiring another company. So you have company G for company Y, and they asked our firm to come in and look at company Y and their performance. Well, when we arrived at company Y, everything that we looked at was done to kind of fuzz the performance question. They were running on software that they were not using in production. They were using similar data, so it was impossible to understand how much of it was cached, how much, if they had any bleed over from one session to the next. A lot of performance bad practices in this case. And as a result, we developed what was called a handicapping index, so our confidence score in our output. There's actually an example of this if you go to jamespulley.com. That's JAMESPULLEY.com, and you'll see a reference to handicap model or handicap index on there, and it will walk you through the types of information that you'll want to collect at your various tiers associated with objective data, such as are configuration files the same or different? Do we have the same amount of data in the system? Are we on a virtual machine versus a physical machine? How many differences do we have in the number of nodes? And with that, you can calculate a score from 0 to 1,000 to give you some sort of confidence in your output from a performance test, assuming your performance test is great as well. So that's an excellent question. It's a difficult question to answer, but I would encourage everyone to go and take a look at that handicapping model. You don't have to take it verbatim, but take it, modify it for use in your environment, and it'll give you at least an objective way to say environment A is dissimilar to environment B in these areas.
Okay, awesome. And so that's all the questions we have here. And so really the last thing, I just want to thank you, James, for a wonderful presentation, and thank everyone for attending today's webinar. Just a quick note, QASource offers a quarterly performance testing newsletter titled PERCast. To find the PERCast newsletter, go to blog.qasource.com. And we also have, James, could you go to your first slide again that has your contact information on it?
Yes, actually it's right here on the question slide again. You can hit me at jpulley@nuco.com. I also have a blog site at jamespulley.com that I referenced just a couple moments ago. And if you want to listen to the Perf Bytes podcast, you can catch that at PerfBytes. That's PERFBYTES.com. And we have an archive that goes back about 4 years of various episodes.
Awesome. Thank you, guys. Have a great day.
Thank you.